8.5, quadratic functions and their graphs. So a graph, quadratic function in the form f of x equals x squared plus k. So recall that if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. Now what are we talking about, a and stuff like that? We're coming from here, f of x equals ax squared plus bx plus c. So when your a is positive, so when it's bigger, when this is positive, it's going to open up. When it's negative, it opens down. So let me draw what that actually looks like. So if we had two parabolas, this one opens up. And when you open up, aren't you smiling? Aren't you happy? Doesn't this look like a smiley face? And aren't you positive when you're smiling? Aren't you feeling good? So this would be f of x equals positive ax squared plus bx plus c. Or, the b and the c can be negatives or positive. All that matters is the a, that it's positive. It needs to be positive. So another one is a frowny face. So when we are a frowny face, most of the time when we're frowning, we're not feeling too good. We're feeling negative. So it's negative ax squared plus bx plus c. And all we care about here is that the a is negative because it's a frowny face. The highest or lowest point on the parabola is the vertex. Axis of symmetry is the line that runs through the vertex and through the middle of the parabola. So the vertex, this would be the vertex. It's the most high or low you can go. So this would be the vertex, and in this case, it's the lowest point. Some extra information. Lowest point, that also means minimum. So when we see these words, minimum, lowest point, all it stands for is the vertex. That's all. Keep that in mind. It's going to be very important. All right, moving on. For our frowny face, this would be the vertex. In this case, it would be the highest point, also known as the maximum. So minimum, maximum just means vertex. Oh, axis of symmetry. So your axis of symmetry is a dotted line that cuts the middle. It literally is in the middle of the vertex. So opposite sides, if you fold it over that line, it goes perfectly on top of each other. So that's what the axis of symmetry is. All right, so when you have a quadratic that is in the form of x squared plus k, if k is positive, the graph goes up k units, and if the k is negative, it goes down k units. All right, so the blue one is the original graph. So we actually call that the parent graph. So the parent graph is something you're going to need to memorize. The parent graph has points of 0, 0, 1, 1, and negative 1, 1. Meaning we plug those in, we get y. But just memorize those points. It's going to save your life, especially in college algebra. So with the parent graph, we're going to go up 3. So do you notice the red graph, everything just goes up 3 units? So for the red graph, we have points 0, 3, 1, 4, and negative 1, 4. So that's for the red graph. For the green graph, it has negative 3. So everything just gets shifted down 3 units. So we would have 0, negative 3, 1, negative 2, and negative 1, negative 2. So that's what that k on the outside means when it's not really with the x. It's on the outside of x. We go up and down. Graphing quadratics in the form of f of x equals x minus h squared. So do you notice this time we have something with the x? we have the minus 3 with the x, the plus 3 with the x. That means we shift left and right because x is left and right. And it's the opposite. So if you have x minus h squared, you shift to the right h units. If you have x plus h squared, you shift left h units. In college algebra, we break that down so much, but for now, it's just a rule we want you to know. All right, so we have our parent function of x squared. So here we have minus 3. That means everything gets shifted to the right 3 units. So everything gets shifted to the right 3 units. And then we have our new points. So for the red one, our vertex is 3, 0, and the axis of symmetry is just the x of the vertex. So this would be the axis of symmetry. It's just the x of the vertex, because that's what it goes through. All right, now for our green graph, it's x plus 3 squared. So that means we go to the left 3 units. So every point gets shifted to the left 3 units. So our new vertex is negative 3, 0, and our axis of symmetry is just x equals negative 3. Remember, it's the x of the vertex. Graph quadratic functions of the form f of x equals x minus h squared plus k. So now we're combining it. So we want to graph x minus 2 squared plus 4. So that means the graph of y equals x squared is going to be shifted 2 units to the right because it's minus 2. And then it's going to go up 4 units. So here is the blue graph is the parent graph. So let's do our transformation. So everything goes right 2, up 4. So here, right 2, up 4, we have our new point. Here, right 2, up 4, we have our new point. Here, right 2, up 4, we have our new point. Right 2, up 4, we have our point. And then right 2, up 4, we have our last point. So every point on the blue graph, just go right 2, up 4. Every point gets shifted right 2 units, and then up 4 units. And then our new vertex is 2, 4. 2, 4. Do you notice? Isn't that the change we did? Didn't we go positive right 2, because right is positive, and then didn't we go up 4, and 4 is positive? Do you think that this gives us the vertex? It does. Want to know why it gives us the vertex? That's literally the form. That's what it's called. This is called vertex form of a quadratic. So when it's in this form, we can pull the vertex out. But do you notice when we pull the vertex out, we take the opposite because negative 2 becomes positive 2? And isn't that what we do when we shift left or right? We do the opposite. So that's what we have to keep in mind here. Graphing the parabola defined by f of x equals ax squared. So if a is positive, the parabola opens upward, and if a is negative, the parabola opens downward. If absolute value of a is greater than 1, the graph of the parabola is narrower, that's a hard word to say, than the graph of y equals x squared. If the absolute value of a is less than 1, the graph of the parabola is wider than the graph of y equals x squared. All right, so now we're going to graph these. So our red one is the parent function, so it's before we do anything to it. Now our blue one, see how a is greater than 1? So it's really close to the y-axis. So remember the y, if you're a big number, you grow fast when you're a big number. So that's why we're close to the y-axis, because we're growing really, really fast. So we want to become more narrow. And think of it, most taller people, they're very slender because they're growing really fast. And then for our green one, we have a is less than 1. So meaning it's a decimal or a fraction. So when a is a decimal or a fraction, we're not growing fast. See how we're closer to the x-axis? It's because we're not growing fast. All right, our only real example is to sketch the graph and the axis of symmetry and state the vertex. So luckily, we're in vertex form here. So when we're in vertex form, we can go ahead and figure out our new graph. So first of all, we're going to find the vertex. So the vertex, the opposite of -2 is 2. And then we have -1, so we leave that. We only flip the number with the x. We only change the number with the x. So our vertex is -2, +2, -1. All right, now that we have the vertex, we're not going to graph anything yet. Let's go ahead and state the axis of symmetry. So the axis of symmetry, I just say axis. It's x equals, and then whatever x is, 2. Awesome. So now we need to figure out what we're starting with. So what's like the parent function here? Because there is no x squared here, and we have this number on the outside. So our parent function, what we're going to start with, we're going to start off with y equals 3x squared. So our original points for y equals x squared, that's 0, 0, 1, 1, and -1, 1. So if we have the 3 on the outside and it's multiplying, our points will now be 0, it's still 0, 0, and then 1, 3, and -1, 3. So do you notice the only thing we changed was the y value? And what we did is we just used the number they gave us of 3. So our parent function is 0, 0, 1, 3, and -1, 3. And it's really narrow, but that's how it should be, right? Because it's a is greater than 1. So to get our new one, our new graph, the first thing we're going to do is plot the vertex. So we plot the vertex at 2, -1. Okay, there's our vertex. And now we're going to plot the axis of symmetry. So it's just a dotted line that goes literally through the point. And we always label it, x equals 2. Now we use our transformations. So using our transformations, we have right 2. So we're going to go right 2 units. Then we're going to go down 1 unit. So every point on the red graph, we're going to shift. So we're going to go right 2, down 1. And isn't that the vertex? Awesome. So right 2, down 1. Then right 2, down 1. We're not going to connect all the dots yet because we use the graph of y equals +3. That's not a positive, it's a negative. So what we need to do is flip every point that we have in the black. So all our points, not the vertex, so you just flip the 2 points. The vertex stays no matter what. So this point right here is 2, 2. No, sorry, 3, 2. That's hard for me to see. And this point right here is 1, 2. So I'm going to bring those out. We have 1, 2, and 3, 2. And we need to flip the y's. Why do we flip the y's? Because this number is not attached to the x. It's on the outside of x. So it has nothing to do with x. We flip the y's. So we're going to change the y value. So we'll have now our graph of 1, -2, and 3, -2. So we're going to plot those. So 1, -2, 3, -2. And then we can connect the dots. So now we have our graph. All right, so the first thing we want to do is pull out that vertex. So for the vertex, remember opposite of positive, so that'd be -5 and then 3. So that's our vertex. And then because of that, we can find our axis, which is x equals -5. From there, we figure out what we need to start with. So we always use that number on the outside. So we're going to start with y equals 4x to the 4th. So remember, our parent function before we do the 4 is 0, 0, 1, 1, -1, 1. So since we have the 4, it's going to become 0, 0, 1, 4, and -1, 4. So the y values just become that number in front. That's it. And it's positive, so we don't need to be careful. Like the previous example, we don't need to be careful. It's already positive, so we're good to go. All right, now we are going to plot the vertex. Or excuse me, plot our... Now we're going to plot our points for the parent function of 0, 0, 1, 4, and -1, 4. And it's a really narrow graph because 4 as being multiplied is a big number. So now we need to plot our vertex of -5. Our axis is symmetry. It just goes straight down. And now we need to shift. So every point on the red graph needs to be shifted to the left 5 units. Because remember, opposite for the x's. So left 5 units, and then up 3 units. So every point, I'm going to go left 5, up 3, and we have our vertex. Awesome. Here, left 5, up 3. Last, the one on the right, so this one right here, we're going to go left 5, up 3. And we connect our dots. You see the axis of symmetry from here to here, it's 1, and from here to here, it's 1, because that's if you fold it over, it goes directly on top of each other.